Picture this. You're sailing through the Caribbean. The year is 1859. It's a beautiful night. Stars are out. Everything's calm. Suddenly, the sky explodes in color. Not just your typical tropical sunset hues, but vibrant dancing sheets of light, stretching from horizon to horizon. This
Yeah.
wasn't any ordinary aurora borealis. This was the Carrington Event, the largest solar storm ever recorded, lighting up the sky as far south as Cuba. Talk about an unexpected light show. Welcome to Cosmos in a Pod, the Space and Astronomy series. Please like, comment, share, and subscribe. This time we're diving deep into the heart of our solar system, the Sun. We'll explore its immense power both as the life-giver we depend on and as a source of unpredictable and potentially devastating space weather.
That's a fantastic way to set the scene. What's always fascinated me about the sun is this duality. It's this constant presence in our lives, providing warmth and light, but it also has this hidden volatile side that can catch us off guard.
It's a cosmic balancing act.
Right.
We're constantly benefiting from its energy, but we also have to be aware of the risks that come with it.
Exactly. And that's what makes studying the sun so important. We need to understand both its life-giving power and its potential for destruction if we want to safely navigate our journey through space.
So let's start at the beginning. Where did this powerful star come from? How did it form?
Well, you have to go back about 4.6 billion years. Imagine a vast, swirling cloud of gas and dust, a nebula stretching across unimaginable distances. Over millions of years, gravity starts to pull this material inward.
Okay, so this cloud starts to collapse in on itself.
Yeah.
What happens then?
As it collapses, it starts to spin faster and faster, like a figure skater pulling their arms in. The center, the core of the swirling cloud, gets incredibly dense and hot, and eventually something amazing happens. The temperature and pressure become so extreme that nuclear fusion ignites.
So that's the birth of a star. The moment fusion starts, boom, you've got a sun.
Precisely. And that process, nuclear fusion, is the engine that powers the sun. It's constantly converting hydrogen into helium in its core, releasing an unbelievable amount of energy in the process.
And that's where our sunlight comes from, right? It's the byproduct of this massive nuclear reaction happening millions of miles away.
That's right. It's fascinating to think that the sunlight we enjoy every day is a direct result of this incredibly powerful process occurring at the sun's core. It's the ultimate form of renewable energy, and it's been sustaining life on Earth for billions of years.
But as we saw with that Caribbean light show you described, the sun's energy isn't always so benign.
That's the thing about the sun. It's a constantly evolving dynamic system, and while it provides the light and warmth that sustain life, it also releases bursts of energy and charged particles that can have a significant impact on our planet.
We're talking about solar flares and coronal mass ejections, right?
You got it. These are essentially massive explosions on the sun's surface, releasing energy that travels through space at incredible speeds. Now imagine a coronal mass ejection. It's like a giant bubble of superheated gas and magnetic fields hurtling towards Earth.
Okay, that sounds a little alarming. What happens when one of these bubbles hits us?
Well, luckily, we have Earth's magnetic field, which acts as a shield deflecting most of this harmful radiation. But sometimes these events can be so powerful that they overwhelm our defenses.
And that's when we see things like the Carrington Event, with auroras visible in the tropics and telegraph systems catching fire.
Exactly. The Carrington Event was a stark reminder that the sun's activity can have a profound impact on our planet, even disrupting technologies that we rely on.
It makes you realize how interconnected we are with the sun, and how even events happening millions of miles away can have a direct impact on our lives.
Absolutely. And as we become more and more reliant on technology, understanding, and predicting space, weather becomes even more crucial.
It sounds like we need to delve deeper into this. What else has the sun thrown at us over the years?
Well, you've touched on one of the big ones, but there are others, and their impacts are pretty fascinating. Let's go back in time a bit to the early 20th century.
Welcome back to Cosmos in a Pod, where we're peeling back the layers of the sun's power and its impact on Earth. You're about to take us back in time to explore some other major solar events.
Right. So let's rewind to 1921, a time when radio communication was still a relatively new technology. Picture this. You're an operator at a busy train station in New York City, relying on radio signals to coordinate train movements. Suddenly, the radio goes haywire, crackling with static and interference.
A bit more disruptive than losing your Wi-Fi for a few minutes, I imagine.
Oh, absolutely. It turned out that a massive solar storm known as the 1921 Railroad Storm had bombarded Earth with charged particles. These particles interacted with Earth's magnetic field, creating powerful electrical currents that wreaked havoc on communication systems.
So even back then, when our reliance on technology was far less than today, solar storms could cause significant disruptions.
It really highlights how vulnerable we are to these events, even with seemingly simple technologies. And it's not just communication systems that are at risk. Remember that Earth's magnetic field helps protect us from the sun's radiation, but it's not foolproof.
You mentioned earlier that sometimes these solar storms can overwhelm our defenses. Can you give us an example of that?
Absolutely. Let's jump ahead a few decades to the 1970s during the Vietnam War. The U.S. Navy had deployed a network of underwater mines off the coast of Vietnam designed to detect enemy ships. But on August 4th, 1972, something strange happened. Dozens of these mines spontaneously exploded.
Wait, so the mines just went off on their own. What caused that?
It took some time for investigators to figure it out, but the culprit turned out to be the sun. A particularly intense solar flare had bombarded Earth with a surge of charged particles. These particles interacted with Earth's magnetic field, triggering the mine's magnetic sensors and causing them to detonate.
Wow, that's incredible. It really shows how solar activity can have unintended consequences, even influencing events on Earth in ways we might not expect.
It's a stark reminder that the sun's influence extends far beyond just providing light and heat. It's a powerful force that can impact our planet in ways we're still discovering.
So we've got exploding mines, disrupted radio communications. Are there any other examples of the sun's disruptive power?
There are many, but perhaps one of the most fascinating is the case of the Pioneer anomaly. In the 1970s and 80s, NASA launched two spacecraft, Pioneer 10 and 11, to explore the outer solar system. As they journeyed farther from the sun, scientists noticed something strange. They were slowing down slightly faster than predicted.
So there was a tiny, unexplained deviation in their trajectories.
Exactly. This discrepancy, dubbed the Pioneer anomaly, puzzled scientists for decades. They considered various explanations, even questioning the laws of physics.
So what was the culprit in the end? Was it some new unknown force?
Not quite. After years of investigation, it turned out that the culprit was thermal radiation from the sun. It was a tiny effect, but over vast distances and long periods of time, the gentle push of solar heat had a measurable impact on the spacecraft's speed.
Wow, that's amazing. Even something as seemingly insignificant as thermal radiation can have an impact on objects in space.
It's a testament to the sun's pervasive influence, reaching even to the farthest corners of our solar system. But let's face it, what everyone really wants to know is, what if a Carrington-level event happened today?
That's the million-dollar question, isn't it?
Yeah.
We've talked about historical events, but how would our modern world, with its dependence on technology, fare against a solar superstorm?
Well, let's just say the consequences could be significant. We're talking potential disruptions to power grids, satellite communications, GPS navigation, essentially anything that relies on electronics.
And I'm guessing it wouldn't just be a minor inconvenience. We're talking potential blackouts, communication outages, maybe even disruptions to financial systems.
You're getting the picture. In today's interconnected world, a major solar storm could have cascading effects across multiple sectors, leading to economic losses and societal disruption.
Okay, that's painted a pretty concerning picture.
Yeah.
But is there anything we can do to prepare for such an event? Are we just sitting ducks waiting for the next solar superstorm?
Not at all. Actually, that brings us to a really exciting area of research and development.
Okay, so there's hope. Tell us more. Welcome back to Cosmos in a Pod. We've been on quite a journey exploring the sun's incredible power and its impact on our planet. We left off on a bit of a cliffhanger. What can we do to prepare for a major solar storm?
Well, you know how they say knowledge is power? That's certainly true when it comes to space weather. The more we understand about the sun's behavior, the better equipped we are to anticipate and mitigate the risks.
So it's all about being proactive rather than reactive.
Exactly. And we're making great strides in that area. One key aspect is improving our ability to forecast solar storms. You see, these events don't just appear out of nowhere. They're often associated with sunspots and other visible features on the sun's surface.
So by monitoring the sun, scientists can identify potential threats before they erupt.
Precisely. We now have a network of space-based observatories like the Solar Dynamics Observatory, constantly monitoring the sun, capturing images and data in multiple wavelengths. It's like having a 247 surveillance system on our nearest star.
That's pretty reassuring. So we've got the eyes on the sun. What about actually protecting our technology from these solar outbursts?
That's where things get really interesting. Think about our power grids. They're essentially vast networks of interconnected wires spanning entire continents. When a solar storm hits, it can induce powerful electrical currents in these wires, potentially overloading transformers and causing widespread blackouts.
Okay, so we need to make our power grids more resilient to these solar-induced currents.
Exactly. And engineers are working on innovative solutions, such as installing special devices that can absorb excess current protecting transformers from damage. There are also efforts to create microgrids, smaller, localized power systems that can operate independently in case the main grid goes down.
So it's all about creating redundancies and backup systems, kind of like having a spare tire for your car just in case.
That's a great analogy. And it's not just about power grids. We're also hardening satellites against radiation, developing backup communication systems, and even exploring ways to create artificial magnetic shields to protect spacecraft and astronauts.
It sounds like a multi-pronged approach is needed, involving both technological innovation and changes to infrastructure.
Absolutely. But there's another crucial element that's often overlooked: public awareness.
Okay, so it's not just about scientists and engineers figuring this out,
Yeah.
but also about educating the public.
Exactly. Imagine if everyone knew the basics of space weather, how to prepare for a potential blankout, how to stay informed during a communication outage, how to protect their electronics. It could make a huge difference in our overall resilience as a society.
So it's about empowering individuals to take ownership of their preparedness, just like we do for other natural disasters.
Precisely. Because at the end of the day, we can't completely control the sun. It's a powerful force of nature, and we have to learn to live with its unpredictable nature.
It's a humbling reminder of our place in the cosmos, isn't it? We're this advanced technological civilization, but we're still at the mercy of the forces beyond our control.
That's the beauty of it. The universe keeps us grounded, reminding us that there's always more to learn and discover. And who knows, maybe someday we'll not only understand the sun's power, but also harness it in ways we can't even imagine today.
Now that's an optimistic thought to end on. Thanks for joining us on this deep dive into the sun, a journey that's taken us from ancient auroras to cutting-edge space weather forecasting.
It's been a pleasure exploring these cosmic connections with you.
And as always, thank you for listening to Cosmos in a Pod. Don't forget to follow and subscribe to Cosmos in a Pod and our YouTube channel. Until next time, keep looking up and pondering the mysteries of the universe.